All right, in this video, we're talking about section 4.4, the applications of the logarithms. There's basically three major applications that you're going to see in this section. The pH formula, so everybody's probably familiar with pH. That's some common application. We know that 7 is the neutral, 1 is the most acidic, and 14 is the most alkaline. So things fall between 1 and 14 on this scale. Again, 7 being neutral. Well, did you know, though, the pH formula for figuring out where you fall on that scale is you take the negative log of what's called the hydronium ion concentration. And so that is given to you in these first two examples. And many of your homework problems, you'll straight up be given those numbers. So like number 1, everybody practice putting this directly in your calculator. You just plug it in for that value, do negative log, parentheses around, and you'll notice that this number is given in scientific notation. So it is typically a scientific notation value, you'll see. And so it'll look like this when you do so. So pH is the negative log in this first example. You should have plugged in 6.3 times 10 to the negative fifth. Type that directly on your calculator. You should get this number, which rounds to be 4.2, which falls between 1 and 14 as we would expect. That's how you know if something's off. You know, your number should be, a reasonable pH number. So on the acidic side. Okay, try it again on number 2. Plug that in your calculator. It should look like this. Negative log, parentheses around the value that's given for H plus. Type that in, equals 3.14. It goes on, but to the nearest tenth, you might round it to 3.1. Again, a little acidic. Okay, so that's how you handle those and those applications. Now on number 3, we're going to work the formula a little differently. We know the pH and we want to figure out what H plus is. What is the value that goes there? And we do want to write it in scientific notation. So pause the video, try plugging in 7.1 for this side of the equation. Think about how you could solve that. All right, so it should look like this. pH is the negative log of this H plus. Or in this case, it's going to be our unknown. I'm going to call it X. So pH being 7.1 given in the problem. And what we don't know is what is the hydronium. And you could have called that H or any variable that you like. But I just went with X. So it would look like that in the formula. 7.1 equals that. So to solve for X, the first thing I would do is divide out that negative sign on each side. Leaving log of X. And notice it's a base 10 log, a common log, just regular base 10 log that you can use on your calculator of some unknown equals negative 7.1. All right, now to solve that, we want to take that out of log form. That's the trick. So over here, just reminding you, if I said log base 10 of 100 equals, the meaning of log is 10 to what power equals 100. So you take this is your base, raised to, this is the exponent to equal this number. So for example, 10 to the second is 100. Well, in these problems, it's got the exponent on the other side. So we kind of look at it backwards. 10 to the second equals 100. But it's the same thing. We could have switched the equal sign. The two sides can be turned around. So taking this out of log form, it's 10 to that power equals X. So it's going to look like that. So that's basically your answer. X equals 10 to that power. But in scientific notation, we would plug that in our calculator and get that decimal value. Then to put it in scientific notation, you'd move your decimal over between the 7 and the 9. And you'd have 7.9 times 10 raised to, it'd be negative 8 because that's how many places you had to move your decimal point to get it between the 7 and the 9. And when we move our decimal to the right, that move, making this very small numbers have negative exponents, it would look like that. Okay, number 4 on your handout. Number 4 says, suppose the hydronium ion concentration of a sample of water found is 4.5 times 10 to the negative third. Classify this wetland. And I guess we need to read this part about classifying wetlands. Wetlands are classified as bogs, fens, marshes, and swamps based on their pH values. Another really neat application sort of from the biology field here. So then it tells you the value between 6 and 7.5 is rich fen, a pH of 3 to 6 is poor, and if it's below 3, it's a bog. So plug that in your calculator just like we've been doing. See what you find. Remember our pH formula. So when we plug in this question number 4, you can type that directly in your calculator. You should get 2.3. And according to our reading, 2.3, which is below 3, classifies as a bog. So we would say that water would make that wetland a bog. So that's pH, the first application. Okay, moving on down, the next application is decibel levels. So decibel levels, that's the loudness of sounds measured in decibels. We find decibels by D decibels equals 10 times log, and again, these are common logs. If you don't see a number, it's base 10. Log base 10 of the intensity of a sound divided by the reference intensity. So the reading up here talks about what I sub O means. So I sub O read I sub 0 or sub, I'm saying I sub O. Sometimes I say that instead of I sub 0 to be more correct. Is the very faint threshold sound, like the smallest detectable sound would be your reference value. So if a particular sound has an intensity I, the intensity is measured, it's that much more than the intensity of the reference. So we do something like this, like in number 5, it says find the decibel of a sound with an intensity 10 million times louder than regular reference, like the smallest thing, reference intensity of sound. So 10 million, and there's an understood little times between that of I sub 0. So plugging that in our formula for I, that's the intensity that goes on top for I, and then it's divided by I sub 0. So plug that in your formula and think about that. And so what you'll see is, here's what it would look like in the formula. Again, here's the formula. 10 times, then log of I over I sub 0. So when we plug in the intensity given as 10 million times I sub O, and then divide it by the I sub O, those cancel because that's multiplied, so you can just cancel them out. So it just looks like that. And that's what you can plug that directly in your calculator, and you should get 70. So 70 for number 5. Okay, then last application is earthquake intensity. Almost the same formula. Instead of having a 10 in front of it, Richter scales, we know whenever earthquakes are measured, they're measured on the Richter scale, and they're between 1 and 10. 10 being terrible, 1 being not much movement, maybe don't feel that. But the way that they measure them is very similar to sound. You divide by the reference, like the normal movement of Earth, the smallest amount that you can feel, that will be the reference intensity. So we'll say how many more times was the movement than normal. So for example, in number 6, if the movement was 1,000 times as powerful as reference, plug that in for I. Then when you divide, these I sub 0s cancel out nicely again. So try that on 6 and 7, please. And so you can see on number 6, 1,000 times the reference intensity. Then when you divide it by that, as per the formula says, these cancel. So you're just looking at the Richter scale is log of 1,000. Type that on your calculator, and that is 3. So the only difference is it just doesn't multiply by 10 like decibel did. And then for number 7, it's 1,000,000 times reference. So it's quite a healthy earthquake there, right? 1,000,000 times more powerful than the reference intensity. Then when you divide it by reference intensity, those cancel out. So we've got log of 1,000,000. Type that on your calculator, and you have a Richter scale rating of 6. All right, and that would be 3 of the basic applications that you see in your 4-4 homework. I hope that helps.